Justin. We started great. We started well. We started with me being muted. Thank you, Justine, for letting me know. Welcome. Today, in this Saturday morning, we're going to start exploring and learning a little bit more about this idea of AI. What can we do with AI? And what are some of the things that our students should learn? Maybe also us. And what material can we use to do that process? My name is Herman, and I'll be your host today. I'm going to be delivering this session and other two sessions throughout the day. The program is called Experience AI, and the idea is educational program that helps teachers and students. It's designed mainly to be student facing so that the students can understand the fundamental concepts of the technology, what it is not, and to be better informed before they tackle and they interact with the technology. We know that our students are using AI, so it's important to know what things work really well and what things don't work so well, and how can we think about these concepts and learn a little bit more. To get started, because I come from an organization called Digital Moment that we're a nonprofit, I have this registration form that I would greatly appreciate if you can fill it in after the session so I know a little bit more about you. I'll be sharing the slides at the end of the session. You will have access to all of this. And something that is important is I'm here to support you. If you have questions, if you have requests, if you want to talk to us, please do so. I'm open to hear your request and to support your journey. I see some comments. Let me see. Perfect. Good. We're going to continue. So, what are we doing today? What are we doing in this hour that we have together to talk about Experience AI and the AI fundamentals? There are three main concepts that I want to touch on. The first one is that by the end of the session, you will have access to high quality instructional materials. That's going to be very important because those are for you. They're free. They're created by the Raspberry Pi Foundation with some other organizations, and I'll share those with you. I'll give you a peek of how they look, and I'll show you how they can be applied in your classroom. Second, we're going to try to consolidate a few fundamental AI concepts, not all of the concepts that are included in Experience AI because it's a comprehensive program, but I'll give you a sneak peek and I'll go over some very key areas that we all should consider. And the last one is that I hope after you see what we're doing today, you gain some more confidence in what this technology is, how it works, and how can you help your students in this new way of learning, interacting, and thinking. The first thing is that, okay, we heard about Digital Moment before kids could use, but who's Herman? And why should we trust you with this information? We've been creating a Digital Moment AI content for about 6 years now, but now we made a little bit of a switch. We know a little bit, we've learned a lot in that process, delivering to teachers and to students, but Experience AI is not created by us. Experience AI is created by the Raspberry Pi Foundation. They are not related with the Raspberry Pis. They're part of the foundation, but they're separate. So what they bring is all their pedagogical background, all their pedagogical knowledge in creating lessons and interesting material that explains and explores digital literacy. Because they're not experts in AI, they have a lot of people that know a lot. They wanted to go and reach out to experts, so they collaborated with Google DeepMind. So DeepMind provides all the information regarding the technical side of AI, Raspberry Pi Foundation, the pedagogical side on digital education, and they also partnered with the Cambridge University. They had some researchers in order for them to validate and to explore and to help with the lessons. These lessons are going to be, or they are already in English and in French, so you have them accessible in Canada. They're being translated into many other languages and they're being launched all over the world. In this moment, Digital Moment is distributing them all throughout Canada. So That's the people that made this, and this validates why this can be important. Now, how do they look? Should I pay attention? Is this something that me as a teacher that doesn't know much about AI, or maybe I'm not fully technical, can I use? What do I need? What should I know as an educator? And what do I get? I'm going to give you what I call a mini tour. So let me go. If I click here, you're going to have access to Experience AI. And this is Experience AI, the main site. And as you can see, I'm logged in. You can create an account for free. You don't need us, you don't need anything else. And I have not received one email after I create the account advertising anything. It has a lot of the information, but I want to show you today is the lessons. How do the lessons look and why are they applicable and valuable for you and your students? If I go to the lessons, then I see that I have three main blocks. The first one is we have foundations of AI. That's what we're talking in this session. AI and safety. That's something that we're going to talk about in the third session. They're very new compared to the other content, and they have a different approach that is very hands-on, and it presents a different way of engaging and thinking about safety and AI. And they have individual lessons. The beauty is that once you have this, they keep adding things that are being changed, improved, and all the material is going to live here for you. If we take a look at the foundations of AI, if I click on view the resources, we have a bunch of information that should make you feel a little bit more comfortable. You have overview of everything. You have learning graphs with different methodologies, and you have a big educator guide. But beyond that, at each one of the lessons, you get the following. You get an introduction, very light, and then you get a video from the Raspberry Pi Foundation explaining. Yes, Nicholas, I'll share the slides right after the presentation. Thank you for asking, for sure. Then we're going to have a video that explains this is why we're learning this. This is the process that we use to create it, and this is why we chose this methodology. So it gives you some background, but then you have access to a lesson plan. You have the slide decks. The slides you're going to see, 99% of them come from these resources. And then you have different activities. In some of them, you have access to also, uh, I got stuck. I don't remember, but there are many more things. So we have lesson plans, slide decks, activity sheets, and we have assessments in sometimes. You can use or access those online, or you can choose to download them if you're going to use them in a place where you don't have internet connectivity. So that is the big picture, and then it guides non-technical teachers and educators on how to explore AI with their students. Let's take a look and let's see what else we have then. So we know who made it, we know how it looks. Then there are some concepts that are key to embark in all this journey about pedagogy. We're going to explore two that are going to help you understand kind of the sense of the lessons, and it's going to help us start thinking and talking in a different way about AI. The first question we have is that we can ask this to ourselves. If we're describing what a smart speaker does to an 8-year-old, try to think, what words will you use? How will you explain this so it provides enough information without overwhelming and addressing that age group? So try to answer that question in your mind. What will you do? If you want to put it in the chat, you can put it in the chat. But I know it's early Saturday morning. Maybe you don't want to put things in the chat, but that is fine. The idea is that I want you to think now in that process, in those sentences, in those words, did you use understands or listens? I've done that many times. I still do it even after what we're going to see now. It's an interesting concept. Should we use understands and listens? Why or why not? And if not, what can we use instead of these words? Let's take a pick. We're going to say that we should avoid those because it's very dangerous to anthropomorphize. As humans, we're great at anthropomorphizing. I always say that when I look at my desk, everything that I see, I can easily anthropomorphize one way or another. And we want to avoid anthropomorphizing. Even having AI represented by this friendly and smiley robot, it's something that goes in detriment in our understanding of the technology, and especially we are hurting our students and their interaction with their technology and their view in the future. Why? There's one big concept with two consequences. The first one is when we anthropomorphize, we're distracting, we're bypassing the human in charge of creating, maintaining, supervising, and improving the technology. And that's all of us in certain ways, and especially the people that are creating these technologies. We don't want to bypass. Why don't we want to bypass it? There are many reasons, but one of them is that if your students, you or me, are finding that the need to learn diminishes because AI does it, AI knows it, then what is happening with our understanding of the world and our capacity to learn? We feel demotivated. We need to understand that we're part of the cycle. This is a tool that is going to help us, but we still need to be conscious of being critical in the way we think, and computational thinking model is still going to benefit us now and in the future, regardless of how AI evolves. That's very important. We don't want to disengage or instill despair in our students. The other one is that if we detach AI from their creators, their maintainers, then what we're doing is that we're bypassing that responsibility. The biases, the problems, the hallucinations, it's AI that is doing it. But in reality, it's not AI. AI is responding to the training for the process that it went through in order to be what it is. Then how can we avoid these words that we said as listens, understands? We have some options. One of them, instead of learn or does, then we involve the human in the middle. These are applications designed to, somebody designed them, somebody trained them, somebody created them. And idea developers build applications, human in the middle, very different. The technology is going to support us, but still, we're here and we're still doing things. The second part is that we can use words instead of seeing, look, recognize, create, make. We use something that is more systematic or more machine like, where we detect, we have inputs, we do pattern matching, we generate, we produce, we predict. And we don't use AI or machine learning as a countable noun, meaning that we don't say AI does this. AI, we can use it more like biology or physics or math. It's a branch, is a field that is doing this and that. So it's a big idea. I invite you to try and shift the way you think about it and the way you communicate it to your students. As I said before, I struggle with this a lot, and I'm sure I'm going to struggle with it today, but it helps me think in a different way. The second part is that we have a shift. It's not a replacement, but there's a shift. We've been exploring and talking to our students and teaching to our students for many years about computational thinking 1.0, meaning the rule-based system where we apply the composition, pattern matching or recognition, abstraction, and then the creation of algorithms when we're creating and when we're coding. One of the important parts about this is that computational thinking is, we can learn it really well when we're learning how to code, but it's not only to be applied when we're coding. Computational thinking is a framework that supports the way that we approach problems and opportunities in the real life. And that's one of the things that our students get from this process. They don't need to become developers, but they understand that they have a problem. If they break the problem into smaller pieces, they do the composition, they can start solving smaller pieces that can have start solving the problem or taking opportunity of that new situation they have at hand. Pattern recognition, we've been teaching this to students since kindergarten. That's how we taught them how to write, how to do math. And then this is something that is important when we have those pieces. How do we start structuring? Then we abstract, because when we're communicating to a machine, then we cannot use the same language in computational thinking point one that I'm using with you. So we need to shift it, abstract it to something that the system will understand, or to simplify the process. And at the end, we have an algorithm. It can be something in coding, or it can be a recipe. We modify, we simplify, we make it more palatable. So that's computational thinking point one, 1.0 that we had for a long time. And now it has a friend that is computational thinking 2.0. And computational thinking 2.0 now is not rule based. We don't give it the rules. We don't come up with the way that the algorithm is going to work step by step. It is database. And in this case, we think about the problem or the opportunity. We think, what data do we need to solve this problem or take advantage of the opportunity? And we start collecting the data we want. Is it images? Is it text? Is it the links? Is it numbers? Is it data? What type of data do we need? After we collect the data, we process that data. We're going to see how shortly. And then we train. We have the model do the training with that data to start doing itself the composition, pattern recognition, abstraction, and creating the algorithm. In a way, computational thinking 2.0 is doing computational thinking 1.0 here. And then we evaluate to make sure that the process works, and we refine. They are not exclusive. There are two different approaches, but with artificial intelligence, this is the one that we're favoring. Now, having that into account, we're going to take a look at three examples and think, can this be done with AI or not? Considering that we're saying AI, computational thinking 2.0, or without AI, computational thinking 1.0. The first one, we say a spreadsheet that uses formulas to work out the total cost of a holiday. We've done this maybe in a spreadsheet or a piece of paper, or in our mind if we have a trip, or if we're going to a store, or if we're going across the world. We know we can do it in a spreadsheet. We know we can do it in a piece of paper. So that works pretty well. But I always like to think, how could I do this with data? Maybe it will be much better, it will be much easier. But then I start thinking, what data do I need? If I'm going to another country, then it will be good for me to have some historic data of what does it take for me to go there. Maybe that is the data that represents me, but maybe it's too old. So I will need some generic data that gives me information about how most people do it. And also I need data that is relevant to the time that I'm going, something that is timely. So the problem starts ballooning, 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 and it might be possible, but it's overkill. We can do this very easily in a spreadsheet or a piece of paper. If we go to the second one, now we're saying online streaming service that recommends films based on users' viewing habits. So let's think, how can we do this on a spreadsheet or manually or code? Can it be done? I think it can be done, because then I say, Nicholas likes horror movies. Oh, he watched this movie that's categorized as horror movies. So if I said, is the person watch a horror movie, and then I recommend these other horror movies. So it can be done. It's very time consuming, it's very involved, and maybe it's way too simplistic. Because if I can provide lots of data, not only what I watch, but what everybody in the platform watches and the way that they interact with the content while they watch, meaning do they pause, do they leave before the movie ends or at the beginning, then I have more information that the system can explore and give me a better representation of what can I recommend. So in this case, AI sounds much more palatable. And the last one, a chatbot service that tries to solve common problems that customers usually have. If we think today will be an immediate answer that maybe your students are going to say, no, AI, of course, is a chatbot, ChatGPT or Gemini or Claude, they're all chatbots. So yes, that will be perfect. But not all chatbots are created equal. We used chatbots for a long time without AI that were coded, and there's still a room for those chatbots that are not AI. Maybe you want to have full control of the information that the chatbot provides. So in that case, maybe you use AI to try and recognize what is the information that the user is asking for, but then you provide a can answer because you want to have control of the information. Maybe you're an airline and you want the chatbot to provide a very precise information within a very precise way of writing it. Maybe you don't want the chatbot to go and start giving discounts to everybody. So this is one of the ideas. This is one section of Experience AI. It simplified it a lot, but it provides the context and the concept of let's think about this, let's see it in different scenarios, and let's ask some questions. Usually these questions are recommended to do in a think, pair, share, or there are some pages to print and to work as groups and ideate and explore these topics. The second one is that I have also a snippet of the second part, how computers learn from data. In this case, what we're going to say they learn via machine learning. And then we could go into the discussion of AI being the superset, machine learning the subset. That's also part of the learning. We're going to ignore that part for now and just focus on what is this machine learning? What is this doing? And the key part is that we have two words here, models and models. And then we need to think that the machine learning, what it's trying to do is to create a model. And if we think a model is a representation of something, it can be a building that an architect just makes first in a model in order to explore, to see interesting things, to pitch to potential buyers, and for engineers to analyze potential challenges. So we're creating a representation of the real world. And machine learning is trying to do so, to create a representation of the real world by using data and pattern recognition and statistical methods. Then once the model is created, the idea is that that model is going to make a prediction. It's going to tell us, this is what I think that should happen. Or in the case of the LLMs, this I think the next word that should come should be this, and then builds the sentence. And when we think about AlphaFold and protein folding, then it's also doing the same thing. It has a representation, and given certain conditions, is going to make a prediction of what is going to happen or what it expects to happen, and it will make that prediction, giving us an uncertainty level. This is how sure I am, or this is how unsure I am. And that prediction is going to help us make a decision. So the idea of machine learning is this system that is going to create models, representation of the real world, that are going to help us make predictions with a certain level of certainty or uncertainty. That sounds interesting. I didn't talk about this with Justine. Of all this, I have one video that I want to show to you. Please let me know in the chat if you don't hear the video. These videos that I'm going to show, only one, each session has one or more, and they are customer facing. and I'm being very blunt in saying customer facing, it means that your students can see them and explains concepts directly from engineers at Google DeepMind. So let me play the video, and if you don't hear, please let me know. I see we have an issue with the sound. So what we can do is that we can skip the video, but I'm going to show you three key parts within the video. Not a problem, it's not a big deal. What I like about the videos is the following. First, in the videos, you have as a common person in all of them, this person. Salome is a computer science student, and then she's asking questions to different researchers at DeepMind, and they explain these concepts. So in this case, we're talking about machine learning and about three different types. Watch the video YouTube. Yeah, that can be there, but you're going to have that on the slides. Don't stress about it. So we have three ideas. We have supervised learning, unsupervised learning, and machine learning. We're going to start with supervised learning. And what I want to show you with supervised learning and why I like showing this video is that the way that they explain supervised learning is that it's a system that requires lots of examples. All those examples need to be labeled. And then they present this illustration and a representation of how humans can learn in a classroom. This is not a real scenario, but a way to understand and to think about the concept. So we're saying that we're learning about mammals and reptiles. And we're doing this by the teacher presenting an image and asking their students, is this a mammal or a reptile? And then one of the kids says, it's a mammal, but it turns that it's a lizard. And then the teacher says, no, it's a reptile. And they keep doing this exercise over and over. So it's supervised learning because we have many examples. Those examples are labeled, and then we provide answers to the system. The system guesses, and then we give the right answer. When that happens, the system starts making their making a little bit more accurate. The way that is explained here is that if a human did this with thousands of images, we will get really good at differentiating mammals from reptiles. We will start catching on specific things such as the skin, maybe the way they move, many different attributes, and the system is going to do the same. Very important to say here now, what we heard about the concept of the black box also applies. We don't know exactly what the system is choosing to determine if something is a mammal or a reptile. That is work that is being done, but most of these systems, there's one that is very transparent, they are not transparent. We don't know what the system is choosing, and we're going to see that in the next exercise. So it'll be supervised learning. The second one will be unsupervised learning. So I'm going over those, and what I want to show you with unsupervised learning is, I'm going to stop right here. Not meaningful, but the idea of the streaming service or a shopping site is that unsupervised learning works really well. Because in this case, we just provide information, we just provide data, and the system is really good at clustering, at finding different groups, at finding different patterns. So as we were saying before, what can happen is that then, according to what I see, not just one movie, not one genre, but how long did I watch it? How many of these type things have I watched? How many did I finish watching? What times do I do that? And comparing it with the rest of the data, they put me in a group. And that group has the tendency to see these videos, movies, or buy these specific items. So in this one, the data does not need to be labeled, still needs lots of information, and is very good at clustering. And the third one, this I love the explanation because is reinforcement learning. And this is explained by cooking. It's a great example because the first dish that all of us ever made in our lives, it wasn't that great, to be very generous. It was worse than not very great. And what happens is that then we learn a little bit from it and we get better and we get better and we get better. Every time then we taste it, it tastes better. We give it to our loved ones and they don't make ugly faces. They're going, haha, great. So we are learning from the process. This is very common. Maybe you've seen of people doing reinforcement learning with video games, where they have the video game play a level on their own. They don't even know what are the goals or what are the objectives or the rules. They figure that out as they go. So those are the three that are explained in those videos. As you can see, the videos are 3-4 minutes and they are very well crafted and they pack a lot of information in a small package with very clear concepts. I hope that was clear enough, but you have a chance to watch it after. Now we're going to do an exercise. I think I have three. We're going to go over this. We're going to have a question and we're going to say, is this supervised, unsupervised, or reinforced? And think about what I said at the beginning. Think about this in front of your students. You talk about machine learning models, then you went and showed the video. Now you're doing an activity to reinforce the concept. You can do it in groups or with everybody at once. The first one, something that learns by trial and error. We just saw it. So the idea, I'm not going to dwell on this, is reinforcement learning because it's learning as it does. The other one that requires lots of label training data. The key here is it requires a lot of data and needs to be labeled. And that's the part that opens another conversation with the ethical use of labeling and label many different things that we're not going to explore here today, but are great within the classroom. So we know that this is supervised learning. And the last one is that easy peasy because groups data that is similar. So we saw the case of the shopping center or the shopping site or the video. And at the end, we have a recap that we provide information to our students for them to have the tools and very simple bullet points of things that they need to keep in mind in order to remember and assess different models. So we're understanding fundamentals. We're understanding how these researchers are working. How do they use these things and what are they thinking? And we've been thinking now since we went to Computational Thinking 2.0 about data and how can we use data in order to produce artificial intelligence. Now that we work with data, we have ideas of supervised and supervised on reinforcement learning, then what we're going to think now and explore with our students is bias. I have this and another activity. Very likely, you're going to see me do only this one, depending how long it takes. But don't worry, everything is in the slides, everything's in the material. Bias, it's a key part in artificial intelligence. The way that we're going to do it is that we're not going to talk about bias yet. What we're going to do is an activity. And this is one of the activities that is within the package with a video explaining everything that I'm going to show you and with very clear instructions. And the idea is that you get to have you and your students, or you or groups of your students, have their own company. We've been hired today by a company called Supermarket AI. And what they're trying to do is what we've seen some stores have tried is that once you pick something, you can walk out of with that thing from the store and you will be charged to your account. So no need to go to checkout. We know there have been many challenges, but we're going to explore and say to Supermarket AI, that is a good idea if we have now the technical expertise to implement this. Because we're getting started and it's a proof of concept, we're going to start just with apples and tomatoes. So the cameras are going to recognize when somebody picks up an apple or a tomato and walks out of the store. And then we're going to build them. That is the goal. How are we going to do that? The first thing is that we need to think, if the case is that we want cameras to recognize people picking apples or tomatoes, what data do we need? This works really well with your students. We're tying all this content to data. Now they need to start thinking, if it's data, what data do I use? The idea is that you should get 2 images, lots of images of apples and tomatoes. We're going to talk about those type of images shortly. And the other thing is that, is it reinforcement, unsupervised, or supervised? And this opens the conversation. It can be done in different ways. We're going to do it with supervised learning, and it's the one that fits the most, because we're going to have 2 labels, which are apples and tomatoes, and we're going to gather lots of data to add them to those buckets or labels. To do that, in the slides and in the material, you will see that we're going to work with a platform that is open source, that is free, that is called Machine for Learning for Kids. Nobody needs to sign up. You can if you want, but I'm going to show you how it works without signing up. So you don't need to worry about creating logins for your students, and the data that we're going to share doesn't involve anything that involves your students. So it provides a lot of safety and security. And we have another document here that is going to be the training test and data that is provided to us. And all this, as I said, is on Experience AI. So let me access those. I'm going to click on the first one and open Machine Learning for Kids. Perfect. It said expire. I'm not logged in. First time. Nope. Already registered. I don't want to do that. I just want to try without registering. So I open it, and it looks plain and simple like this. Before we jump into the other thing we need to do, we're going to start thinking, okay, we're going to create our project. Do I need a template? Not in this case. We're making this ourselves. So I can go and add a new project. And I can call this project anything we want. I'm going to call it my super duper market. Why not? Project type. Am I recognizing text, images? This should be very clear now because you talk to your students, but then it's showing, yep, we want images. And then the storage, it says, where do you want to store these? On the computer, on the cloud? For this one, it doesn't matter. I'm going to put it in the browser. It's fine. Then I click create. And all I did so far is that now I have my project that is called the Super Duper Market and is recognizing images. So far, so good. Then when I click on it, then it starts guiding me of things we need to do. Let's go from left to right. So we need to provide the examples that we're going to use to train our model. I click on train, and it says, yeah, click on the plus. So we go here. We're going to add a new label. We said before that our labels are apples and tomatoes. So let's put apples. So this will be one label. Then I have my box where I'm going to put different images of apples. Then I add a new label, and this is going to be tomatoes. So now I have apples and tomatoes. Then I have options. I can grab images from the web. I can use the webcam. I can draw, or I can have files. The beauty is that we're not going to use the webcam. That way we don't have issues of privacy or making sure that we're not sharing anything from our students. And what I'm going to do is we have the images that we can use here are provided. So I can click on my training and test data, and I'm going to separate. Put one on one side and the other one on the other side. So we have our training data. We have our images. I'm going to be very nonchalant about the way that I pick my images for apples and tomatoes, but the way that I like to do this with the students is that they get to pick the images, and after they pick the images, we talk about why they pick the images they pick and why should we pick some and maybe no others. It's part of the process. So apples, I'm just going to start clicking and grabbing. and I just put the images that I see here, and I start grabbing. These are apples, an angry apple. Let's put the angry apple, a pretty apple. Let's put this one. Let's put this. I'm gonna put 6. I think we need 3. I'm gonna put 6, so we have this. These are our images for apples. Then I scroll down and do the same thing for the tomatoes. So put tomato, another tomato, and it's very easy to add and it's very intuitive. And then we have control over the process. And as I said, the idea is to be a little bit more mindful of what we're doing, and especially to hear what your students choose. I've seen students tend to choose a lot of cartoony and weird objects, and then the idea is why. So let's leave that part on the side. Let's go back only to this application. So we go back to our project to see what we've done. And then we train. Now we want to learn and test with the images we provided. When I click learn and test, it tells me this is what you've done so far. You collected some images of apples and tomatoes. And this is what you need to do now. Perfect. Let me go here, and it says, let's train. So we train. Takes a little bit of time, not that much time. Great question that many of your students are going to say, but 6 images is not enough. Why with so little? It's because this is not a production system. This is not an educational site that has been tweaked in order to only take that few images and still work pretty well, at least for what we're trying to do. Now we get to test. So it could be with the webcam. We don't want to use the webcam in this case. We want to get from our sheet. We want to get not the training data, but our test data. So very important, we get to talk about training data and test data. That means that I collect 100 samples, 100,000 samples, or 1,000,000 samples. I should not use all those examples to train, because when I'm testing, I'm going to be testing with my training data. So that is not a very good scientific method. I want to test with data that the system has never seen. So the idea is to randomly select a portion of our training data for testing. In this case, the page we have here already did it for us, and some of you might already be asking and saying, this test data has an issue. And the issue, I'm sure one of your students is going to point it out right away, is that we do have apples, but there are not red apples in our training data. So we're going to test with red apples, but the training data only had green apples. The idea is then we test. Now we put it here, we say test, and it recognizes it as an apple with 65% confidence. So small or very little confidence, but it did recognize it. Sometimes it fails miserably, sometimes it works really well. The important part is that now we get to talk of what should we do in order to improve our training data. And we can talk about bias. In this case, our training data has a big bias towards green apples, not towards red apples. And that is a little bit independent of the results we're getting. Because many times I've had a red apple being recognized with a 90-something% confidence. So that sounds pretty good. But then it helps us talk once again about that black box. What is the system using? Our machine learning, is it using the color, the shape, the outer shape, the stem, the reflections? What is it using to determine something as an apple or a tomato? And that is the conversation. This activity opens the door to talk about bias in data and training. Once we explore those things, we did the activity as a group, then we continue here. Let me go back to my slides. And now we get to provide a definition and information after it's being supported by that activity. And we're saying that bias, is when the output of the machine learning favors some things and deprioritizes or excludes others. That definition opens the door for a lot of discussion and thinking, where does bias happen, and why? And we provide two examples or ideas of biases. One, data bias. Data bias is when we give data that does not represent what we're trying to model. Exactly what we just did. We did not provide examples of red apples when we're considering apples in general. So we have red, yellow, green, and the variation. If all those are the apples we are testing for in the supermarket, we should have all of them represented in our training and in our testing biases. Data, sorry. The one that I really, really like, and one of the things that I like the most about artificial intelligence, and it's very tangential, is that it amplifies and reflects societal bias. Because many of the things that we're seeing that AI does when it does it wrong, what it's doing, it's saying, this is what society showed me via the comments from Reddit that I use, or the websites that I created, or the scientists that trained me. We're amplifying that bias and it's coming to us. So it can come from societal bias or data bias as big buckets, but they can be much more granular. And that's a great conversation. And then ideas of how to work with this. How can we reduce bias? Meaning us as users, consumers, and as the people that are working with the systems. One, use large sets of data, but most importantly, make sure the data is representative. So that's one of them. The other one is before training the model, make sure you separate a good chunk for testing. Make it random. And if the random is not giving you enough variety, try to include some variety even manually. And the last one is during the process of designing these things and working with these things, make sure that we included everybody, at least as many people as we can, making sure that we have different backgrounds, opinions, and experiences, so the system is going to be richer. So we've seen a lot. We talk about anthropomorphizing. We talk about the idea of how should we avoid it. We started talking about computational thinking 1, computational thinking 2, and then because we went with 2 exploring data, then we saw things that we can do or how can we do it with or without AI. Then we learn about supervised and reinforcement learning, and now we explore bias. All these things are meant to be one full lesson or a little bit more with your students, but I want to do what I'm trying to do today is to show you the picture, the potential of how this is, and how the content can be introduced and explored by you in a classroom. All these slides, they have, as I showed you before, pages that explain what is the slide meant to say, what are the expected answers from the kids, and some support material. We have about 10 to 15 minutes. What I want to do in these 10 to 15 minutes, I'm going to show you, I'm going to skip a few pieces because I want to show you a third part, and that will be decision trees. Decision trees, we're very familiar with them. We use them all the time. And then we have the concept that we have a root, decision nodes, where we decide if we're going one side or the other, and then we have leaves. So it's a tree that we flip upside down that starts with the root, what is the main concept, and it ends with the leaf by helping anticipate, predict, or decide the outcome of something. Great. Big concept. It can be used, for example, in classifying animals, as we see here. When we have this, we can explore this example. It says, where do we get? So let's try and see. If milk is true, we take a look at our piece of information, and we're saying milk false. So it's not a mammal. We go to the right, and we're feathers. Is feathers true? Then we go, it says feathers is false, meaning that if feathers is false, then we go to backbone, true. Where backbone true? Yes. So we are here, and then we ask, does it have fins? Let me go to fins. Where are they? True. And then we should arrive to fish. Super fast. But remember, this is think per share. This should have been done as activity where you divide your students in groups for them to understand how to navigate a decision tree. Somebody else created decision tree. How can they navigate it? The example is very rich. I'm going to give you a succinct picture. Is that now, instead of animals, we're going to think about, let me see. Perfect. So we have 9 minutes, not a problem, we're good. So what we're going to do is we're going to catalog images from the Hubble telescope. Sorry, Hubble, no, James Webb telescope. I apologize, James Webb. But then what we have is that we're going to try to determine these different stars, and categorize them. And the way that this is done is that you start with your students with 2 cards, and they need to decide what is the decision that they need to make in order to go with a main sequence or a red dwarf. And we're going to work only with temperature. Think this in your classroom. How can this work? What will your students do? How would they make the split with temperature? They can think, and then if I were there, I would say, oh, if it's less than 3,000, it's a red dwarf. If not, it's a main sequence. That is an idea to divide these 2 cards. The other idea is to use it with a mathematical approach where we decide what is the midpoint and we break them there. So we made our first discovery. We have our first breakpoint for these 2 cards. Then we bring another one and we see if that still works. Temperature 477 doesn't work because it's saying us that no, it's a red dwarf. What can we do? We adjust our split, and now it works. After this, there's an activity I'm not showing you where your students do even a more involved separation of more stars. And you have access to all this. But then they realize that this, if we have 57 gigabytes of image per day, it's going to be a monumental task. And that comes this part. We go back to machine learning for kids. I don't need to explain all this to you now, because now you know. Let's go to the project. And first, we made one from scratch. This one, I'm going to copy a template. And there are many projects for you to choose and experiment with. As I said, this is an open source, non-profit site that anybody can use, and it's great for education. We have the one with startups. Why is this a template? Oh, it says, I want to save some data for testing, explains models about ideas. I'm saving about 9%. And then what it changes, if I go to train, I don't need to give it the data. The system already has the data, and it already picked a percentage for testing. We're going to do the training. That's why I can do this fast, and I want to show you the big idea and why decision trees are so important when applicable in machine learning. So this is what we've done. We pick and collect all these images. I'm going to download the test data because it used some test data. It's always different. It's not like the one we have with apples and tomatoes. And we're going to train. While this is training, I'm going to import it. You can import it. It's a CSV. I like to open it here. You could open it with any other tool, but with Google Google Sheets, it works pretty well. So we have this test data, and we bring it here. So this is the data that we're going to use to test all this information. Let's put it as a table so it looks nice and pretty. Then we have that it finished training, and then we're going to provide that data. Let's go and let's do this as we did before. And we're going to pick maybe the first one. This is the temperature. we're going to see if we get a white dwarf. So we give the temperature, we're going to give the radius. So we're going with way more things than what we did before. We only use the temperature. This one is using many more attributes, and the color is blue. And we say test, and it tells me white dwarf. Not only tells me that it's a white dwarf, but it tells me that it's a white dwarf and is 100% confident. What is the thing that is key with a decision tree when we can use it? Is that we can describe the model. We can see what is the decision tree that was created. Very powerful, because now there's not the concept of the black box. I can see exactly what influenced the decision of tackling each one of these. Gonna give you a lot of peace of mind. This, what I did for this, is all in a video in Experience AI, taking you by the hand. Is Salome and somebody else explaining step by step, and there's also a page with all the instructions. So I know I went fast, but the idea is I want you to understand how this can help you and your students think about AI. And one of the things that we have not done with this Experience AI, you have not access to ChatGPT. You have not access anything like that. You're thinking about the concepts. You're learning about the fundamentals, and you're learning about some of the benefits that you can have. Then we have an opportunity to talk about decision trees and for your students to think about it in terms of medicine. Very interesting, and then gets students very excited talking about how uncomfortable they are with AI in medicine, but there are some silver linings, especially when it comes to decision trees. The last thing that I have to tell you is that AI in K-12 education is a three-tier process. The first one is that students and educators, we should learn more about the fundamentals to know what things are, what they're not, and what are the benefits or challenges. That's what Experience AI gives you. Level number two is when we go into quality of practice or quality of life for educators. It's what many of you are doing, is that you use these systems to help you write communications with your students, parents, other teachers, with your administrators. It helps you ideate maybe potential lesson plans. It helps you differentiate. It makes you do all these things. So it's how can you use it for quality of practice? And there are some other resources for that. And the last one is the one that we're all thinking we know, but I think none of us fully know, is the one we're all experimenting. Now, when we start introducing this in the classroom and we see potential benefits and challenges. The last part, these are the other things that we do at Digital Moment. We do free teacher training for you and your students. We have open sessions all the time. We can go to your school or we can do this online. We have other services, and this is me. And we're going to share these slides. If you need any help, if you have questions, Microbit, Scratch, JavaScript, AI, all these things, I'll be happy to connect with you. We can have a chat online, or we can explore things via mail. I told you there's something else. In the slide deck, there are 2 surveys. This will be great to help Raspberry Pi understand how you feel about Experience AI. And the first one I show you is the one that is going to help us continue getting funding on what we do. And that's all I have for you today. I'm really happy that you were here this Saturday with me. If you have any questions or anything in the comment, I'll stay here, and then we'll have another session later on. And thank you very much for posting everything there in the chat, because then Justine is on top of that. Thank you so much. My pleasure, Nicholas. Happy to connect anytime. In the slide is my information. Even if it's just to chat, just let me know. My pleasure. Jenny, QR code. The QR code will be, I can put it here in the screen for the first one, but it's also in the slide deck, and you have access to the slide deck. But yeah, I'm going to put it here because this is very important for us for funding. That'll be great. I hope you have a great rest of the day and a great other 2 sessions coming up.